So let's get to it. We'll look at libraries and header files and what are header files, what is a library, because including a header file is the first thing you do when you write. It's the first line of code that you write. So we'll cover what libraries and header files are. We'll learn how to compile a program. This is something you do when you write every program. After that, you compile it. So this is something we'll learn, and then we'll learn what are variables, data types. These are basic programming course concepts used in every language. So this is something we'll learn. Variables, data types, operators. We learn about different operators used in the C language and in programming in general. And then we move on to more advanced concepts. And the first thing we do is we take user input. We take input or data from the user and do computation with that data. And we use conditional statements like if and else statements. We give our program logic using these statements. We also cover arrays. Arrays are really useful things in computation. And we cover loops. Loops are small chunks of code that do repetitive tasks. Like if there's a task that I have to do 100 times, either I write, and it's the same task. Either I write a line of code for that task 100 times, or I can write it in a loop in way fewer lines. And that's why loops are really important. And we cover the for loop in this course. So we finish, we top it all off with an end of course project, which I'm really excited about. I'm really excited to see all of you guys' end of course project. I'm so the what we'll do in the end of course project is create a game, a guessing game where the user guesses a number that the computer thought came up with, and the computer will give hints to the users, and it's a really nice game, and I'm really excited and looking forward to seeing your end of course projects. And all all the codes that I'll be coding alongside you in this course. I will be writing all the codes in the course videos, in the course lectures. It'll be a hands-on course. There are a lot of assignments, coding assignments. There are a lot of readings, very small readings. I won't have you read too much, 1 2 minute readings, reading assignments, but they're important, but they're not that heavy readings. And and of course project, it's a perfect course to get you started on programming, and we cover a lot of ground. We cover a lot of ground in this course, and it's really hands-on. So I'm really excited about this course. I really hope to see you in the course, and I'm really excited to see your end of course projects. And so I hope you guys will stick around. I hope you guys will join the course, and I hope to see you in the course. Until then. Hey guys, what's up? And in this video, we'll learn or basically start learning how to program in C. So before starting to write your first ever program, you should make sure that your laptop has two things. One is that it has a terminal. So if you have a Mac, it has an inbuilt terminal, so you're good to go. Otherwise, you need a Linux-based machine. So this is a requirement. You must have a Linux-based machine if you want to program in the future. So there are ways to go about it in Windows, but I actually am not a big fan of. I hate Windows, so let's not get into that why that is. But you should definitely have a Linux-based machine, and if you do, you will have a compiler. There's something called a compiler, which basically is used to compile or to run a C program in some sense. So we need the GCC compiler, which is almost always inbuilt in a machine. So just to double check, write GCC double dash version in your terminal, press enter, and you get something printed on the terminal. And if there is something printed on the terminal, this means that you have the GCC compiler. So if you did this, if you're here, if you enter GCC double dash version in your compiler, that means on your terminal, that means that you have a terminal, you have a Linux-based machine, and you have a GCC compiler, and you're good to start programming. If you don't have either of these, I would recommend that you get arranged both of them. So it's very unlikely that your computer or your machine will not have a GCC compiler. So assuming you have a terminal to work in and a GCC compiler, we begin to write our first program in C, and it is the sacred Hello World program. So I'm using the Vim editor because this is something that again comes with the terminal with the Linux-based machine, so you don't have to install anything else. So usually a GCC compiler and a Vim editor comes with the machine, with the terminal, so you don't have to install anything else. And basically, there are no overheads to this video, so you can just quickly start programming without installing things like in-terminal editors if you're not used to them, or what a compiler is, or blah blah blah. So that's why I'm going to be using a Vim editor. Don't don't necessarily have to use a Vim editor. You can use anything, but I like to use it basically. This is the editor I learned programming in, and I really like that. I like to go back to, you know, when a time when I learned how to program. So we first start by creating our first file. So let's call it firstprogram.c. This is the name of the file. If I write vim, and the next thing I write is the name of the file that's being created. And now it's open in the Vim editor. And to enter, if I type anything on the desktop, if I type anything on the desktop, it does not show up. So before being able to enter something here, I have to press the button I, which stands for insert. So now there is insert comes in the window. So this means you can write basically. And the first step to writing a program, a C program, I think there are only 3 lines that we have to write in this program, but there's one more important thing that we write in programs, and these are comments. So anything that's followed by a double slash in a C program is a comment. So just letting you know. So what a comment is something that is not read by the computer. So if when a computer is executing your program, it ignores what's written after the double slashes. That's what a comment is. So let's begin by the first step we do uh, in writing a C program is we include the header files. So to include the header files, I'll let you know what header files are. We use the include, and these brackets, and then this means, okay, this tells the program, hey dude, you have to include something. And there is a special file like this, the file that we've created, it's called firstprogram.c. So it has a .c extension. There's a special file inside your computer and somewhere inside deep within the dark secrets of a computer world, and you don't know where it is. But when you write #include stdio.h, stdio.h is a .h file that is present somewhere inside your computer, and when you write #include, the program includes that file. Now, what is an stdio.h file? Stdio.h file stands for, if I write it here, so anything after double slashes is a comment, so I can write anything here and the computer does absolutely ignores it, but only the things that are written after the double slashes. So the computer would interpret #include, but it will ignore whatever is written after the double slashes. So stdio.h stands for standard input output. So this is a file that has instructions about standard input output techniques. So you don't need to go much into the details of what an stdio.h file is, but it's just that you really need to include this, or you really need to write this line if you want to write any program. So this is the first line, first thing that you do if you want to include, if you want to write a C program. Uh, yeah, and just the second thing you do is you write int main, and you just put two brackets, put a pair of brackets. And so this is how I like to write it. And then you put a bunch of curly brackets. So, um, and int main basically signifies that this is the main body of the program that you're writing. And anything about the program that you write is present inside this, in these curly brackets. So anything that you write in the program that you're writing is present inside these curly braces. And that's basically it. So these two are kind of the standard steps that you must take. Uh, this would, I would say, is step one. Include the standard input output, sorry, include the standard input output library. So this is this file called stdio.h is a library. It's called a library. Library is a collection of books. So I mean, just don't need to go into details of why it's called library, but it's like include. The first step is to include libraries. So the first step in writing a C program is to include libraries. There are more libraries that we include, and we commonly do it. But stdio.h is the library we include in every C program. So the first step is to include libraries. The second step is to just write main. I guess that's what I should call it. Just write main, and so this is where you're creating the main part of the program. So these two things are some things that you must do, or you will always do, to write your program. So this is, say, step two. And then whatever you want to write in your program comes within these curly brackets. So within these curly brackets exists your program. And what we want to do here is we want to print hello world in our terminal. So we want to print it as an output. And the command to print something in C is printf. And how you do it is you write the command printf, and you want to write some text. So something that's interpreted as text. And the way you do it is you include that text in double brackets, double quotes. So I want to write hello world, and I include this in the double quote, and every statement in C has to end with a semicolon. So if it doesn't end with a semicolon, so if it doesn't end with a semicolon, uh, I will get an error, and it says an error is generated because I should have included a semicolon after the printf command. So basically, every command needs to end with a semicolon, which is a very irritating part of C language, which you start getting irritated about when you learn more languages. But here, just you have to include a semicolon after every language. Sorry, after every line, after every line of code, and that's it. You're kind of done. I want to include one more thing, but I just want to tell you how it looks without the thing I want to include. So basically, our first program is almost ready. You can say 99% ready. There's just one or two characters that are missing. And the next thing we have to do is that we have to, also to exit the Vim editor, what we have to do is we have to first press escape when you're in the writing mode. So let's say I'm in the insert mode. It says insert over here, right? It says insert over here. To get out of the insert mode, you have to press escape, and then you have to press colon. So a colon comes up. Then you have to press WQ, and this, what it does is W stands for save. So it saves what you wrote, and Q stands for quit. So it quits what you quits the file, and when you press colon WQ enter, you come out of the file magically when you appear in the terminal. So escape colon WQ to escape the Vim file. So to open it, just have to write Vim first program.c, and to escape when you're in the insert mode, to go in the insert mode, press I, and to escape, come out of the file, write escape, then colon WQ, and you're out. And now we've written our C code. Now what we have to do is we have to compile our file. So if I gotta write it down, uh, the first step is write your C program, of course. The second step is compile your file, and this is done using the following line. Just with time you'll understand what these things mean and why certain thing is done the way it is. But right now, just I guess just uh, remember what I did. So I write GCC first program.c. Remember, GCC is the compiler that I use to compile the C file. And when I write GCC first program.c, this statement means that compile the file first program.c. Then I write -o. This means compile the file first program.c into an output file. That's what -o signifies. And what I write after that is the name of the output file. So what happens right now, what's happening right now is, say this folder contains just one file, which is called the first program.c, which is the file that contains the code. Now I write gcc first program.c -o first program. That's all I write. This is now an executable. So what is an executable? An executable is something that's, say, it's basically a compiled version of file that if you run that executable, the program runs. So running the program is a two-step process. The first step is to compile the program into an executable. So when you write gcc first program.c, it compiles the file first program.c into an executable, which I name first program.c. And when I enter this, I first of all don't get any errors. And now if you see the contents of this folder, there is a file called firstprogram.c, which was already present in it. And there is another file called firstprogram. And this is the executable that I created. And remember, this is called first program because I wrote first program over here. Now, if I would have written something else, let's say there just exists first program.c in this folder. If I had written something else like first program again uh, and compiled it, now my executable is called first program again, or you could give it any stupid name. So let me just go back and give it the name first program. So it just contains first program, and then I give it the name. I enter gcc first program.c -o first program. So what this does is now I have two files, the program and the compiled version ready to execute, called first program. And to execute this program, now finally we're at the step where we can run our program. And the way to do it is use // and type the name of the executable. Okay, type the name of the executable and enter, and you see that hello world is printed on your terminal. That's how easy it is. And I mean, it's, it takes a while to learn all these things, but these are things that you always do. So this becomes, this becomes second nature, like including standard libraries, writing into main, uh, compiling the program, executing it using dot slash first program. These things become second nature, so you don't even notice doing these things. So this is great. I printed the message I wanted to print, which just say hello to the programming world, hello world. But I don't like this because it's in the same line as this stupid thing. So what I do here is that I go back to my program and I edit it. What I did was I did not add a line break to my program. And how you add a line break is you enter this slash n, and this means that now I'll have a line break after hello world. So again, compile the program into an output file called first program. So call it first program, and now you have an output file called the first program, and now execute it by saying dot slash the name of the output file, which is first program, enter it, and now I have a line break. So this is how line breaks work. Uh, if you want to add a line break above this or below this, you could just as well do it. You could just add a printf statement that just contains the line break. So just this one just has a line break. Just to use this print statement, you will never actually write it. Just have a line break here, and you compile it again, and then when you run it, you get a line break above hello world, and a line break at hello world, and a line break after the line of hello world. Now, what people usually do is we don't write a special printf statement for a line break. Usually, what you would do to replicate what I just wrote was to include two line breaks here and a line break before the hello world statement, and this does the exact same thing again. Compile and execute, and you get the hello world with line breaks. So this is basically it. uh, so if I jot down what we learned today, uh, what we learned was how to comment in C, how to write a C program, and this had 3 steps, or basically 3 steps. Include libraries, start the main file, I guess that's what I call, and write. So these are the 3 steps to write a program. So first thing we learned is how to comment using double slashes, then writing a program, then compiling a C program or a .c file into an executable. So these are words that I'm sure you guys, I mean, it takes a while to understand what these things exactly mean, but these are words that I'll be using all the time. And the fourth step is running an executable, I guess. Running an executable, or yeah. And this we do using the dot slash name of file, name of executable, and this is done using GCC name of file dot c minus o into output, name of, sorry, there should be no space here, name of executable. Yeah, so This is what we kind of learned today, and this was your first C program. So I hope you enjoyed writing your first C program. All the codes will be available, but I don't think you'll need them, but just in case. So thanks for watching, and I hope you enjoy learning C. See you on the next video. Hey guys, welcome to this next video where we learn how to add two numbers in C, in the C language. So this is the next step towards your journey towards learning the amazing C language. I love this language. Not right now, but I used to love it once because this was the first programming language that I learned 5, 6 years ago or something. So we will add two numbers. So to do that, let's create a .c file which says add, which I call add two numbers. You could call it anything. So .c, sorry. And let's begin with the two things that you do in every C file. You include the libraries. So #include. We use the standard input-output library, so we include that, and you write int main and the curly brackets. And remember, all the code that you write comes within these curly brackets, mostly. And this main line or command is a function. Functions are certain aspects of the C language that you will learn as we go ahead in our journey towards learning the C language. But this is where the body of the code starts, as you might remember from the last video. So I want to add two numbers now. How can I add two numbers? Well, the most easiest thing is to write 5 plus 7, right? But before I can actually add two numbers, think about it. I might want to add 5 plus 3 right now, but I might also want to use the result of 5 plus 3 later in my code. Or I might want to add 5 plus 3 right now, but tomorrow I might want to add 19 plus 21. So, and I don't want to hard code everything. Hard coding is not a good thing. You'll understand maybe with experience that hard coding is not such a good thing. So what we need is basically a place where we can store the numbers that we might want to add or use later, right? And the places where we store these numbers are called variables. So variables are places that we store data, any kind of data. It could be an integer, it could be a character, it could be other kinds of data, real numbers, stuff like that. So these are stored in variables, and variables are defined as data types in C. So what are data types? Data types are different kinds of variables. Like an integer is a variable. So it's a variable could be an integer. So a data type is an integer. Or it could be a character. So a data type is a character. So remember, a variable and data types are kind of two different things. Variable is something that stores your data, and data type is basically telling you what kind of data it is. So right now in this code, I'll write a code that adds two integers. So the data type I'll be dealing with is integers. So this program is written again in steps. Sorry, step one. So the step one here is create variables. Create your variables, man. So I'm adding integers right now. So the two variables I create are A, B. I want to add A, B. And I want to store the result in result. So result is the third variable. So this step of creating variables is called declaration. So declare your variables. This is step one. Step two is initialize your variables. So what does initialize mean? So right now I told my program that, hey, dude, wherever you encounter the letter A or the letter B or the word result, it's a variable now. It's not just anything, it means something. And what it means is that it stores a value, and this value is something that we initialize in step 2. So let's say A is 3, B is 5, and the result is supposed to be the sum of A plus B. So this is basically the program. So let's say this is step 2 and the step 3 is add. So this is a 3-step program. Declare your variables, initialize them, and add them. And then another thing you can do is print, right? Print your variables. So remember, the way you print is using printf command, then whatever you want to print comes within this bracket, and you end every command, every statement in C using a semicolon. So I've used it after every statement. The double slash means common, so this line is ignored by the computer when he reads the program to process it. And now I have to print. So in the last video we printed hello world. So this is something that comes inside double quotes. Now I want to print that the answer is equal to the answer, which is in our case 8. So I want to print 8, but I don't want to print 8 because if I change 5 here, the result should be 10, right? But it'll still print 8 because whatever comes within the double quotes is printed as it is. But I want to print the result, so the variable result. How do I print variables? So the question that is answered here is how do I print variables? So how you print variables is you tell the computer that, hey, dude, this place at this point I want to print a variable. And how do you tell that to a computer? You put a placeholder there. You put a placeholder, like it's like reserving a seat. You put your jacket on your seat, and for a guy that's about to come, right? And same way you put a placeholder in the printf statement in the double quotes, which is a placeholder for an integer. So the placeholder for an integer is called $d. So this is the placeholder for an integer. This $d uh, is the line break as we discussed in the last lecture. And $d is the placeholder for an integer. So it prints an integer here. And the way you do it is you specify that variable after the double quotes. So after the double quotes, make sure you put a comma here, and then you write the name of the variable. So this is it. Let's see what it prints. And let's see if it prints what you expect it to print. So this is compiling the program, and now I want to execute it. Now just see the contents of the folder. It contains 2 files, add 2 numbers.c and add 2 numbers. So let's execute it. /execution, and it says the answer is 10. So it does print what we wanted it to print. Now let's change the numbers a bit. Let's go back to 3. And what if I want to print multiple integers, like say the answer of I want to write the answer of 3 plus 5 is equal to 8. So how do I do it? The way to do it is put a placeholder for A. So again a %d. Then put a placeholder for another integer, which is B. Again a %d. equal to comes is printed as it is, the plus sign is printed as it is, and then we have another integer placeholder. And these placeholders are so how when I have specified a placeholder, now I also have to specify the variables that will be printed in place of that placeholder, and these are done in order of writing them. So the first person D will print A, the variable A, the second person D will print the variable B, and the third person D will print the result. So let's see what this prints. So compiling and executing says the answer of 3 plus 5 is equal to 8. Now I've been able to write a program that adds to numbers. This is all I wanted to do. Just a couple of comments. Note here that all the code that I'm writing inside the main function is, say, 2 blank spaces to the right. This thing is called indentation. Indentation is something you do because it makes the code more readable, and especially when the code becomes huge, and indentation has real importance in programming. So you should always indent your code in some way or the other. People have different ways to indent their code. I have a certain way where if I use the Vim editor, I use 2 blank spaces. If I use another editor, I use a tab, or it depends on what I'm doing. So right now I'm using 2 blank spaces. It's good to indent your code. You should always do it. And this was one thing I wanted you guys to notice. The other thing is why hard coding is not a good thing is because now if I want to add 2 numbers, I can just change the 2 numbers here, and this will find the result automatically, and this will use print this print statement, and all I need to do is change it over here. Otherwise, if I had hard coded it, which means I would not have used variables, I would have to change it all the time. I mean, I would have to, if I had no variables, would have to write 3, 5 again, change it in the code further as well. I think it becomes clearer as we program and write bigger codes, but it's not good to hard code. Always use variables. Remember that. Another thing, always declare your variables at the beginning of the program. So this is a standard that's used. Always declare all your variables in the beginning of the program, but all together. Don't declare them separately. And declaration is also something that's an old-fashioned thing. It's used in C language. It was used in Fortran, C++. You don't really have to declare things in Python, but you have to sometimes. So always declare it in the beginning. It kind of is good practice. And always indent your code. Yeah, that's basically it. That's basically programming using variables, using the integer data type, and adding 2 numbers. So in the next video, we'll look at certain other data types and see how we can use them to write more interesting programs and do more stuff with the C language. So until then, see you guys later. Hope you enjoy learning. If you Hey guys, welcome to this new video, and in this video we'll learn how to multiply two numbers. So we already learned how to add two numbers, and there we used the integer data types. When we multiply the numbers, we'll delve deeper into variables and other data types. So it's not just boring stuff where I make you replace the plus sign with the multiplication sign. I'm just doing it because using something else so that we write a new program doesn't get boring, and you get to learn something else. So here we multiply the numbers, and we'll do it using certain different data types. So just like I said, the first step is to include the libraries. So include the standard input output library. Then every program starts with the main function. So we have int main. Now let's begin. I want to multiply the numbers. Now, again, we'll have to use data variables to store those numbers first. So in the last video, we used integers. In this video, we use another type of data type, which is called, or basically, we in the last video we added two integers, like 5 plus 3 is 8. But in this case, we're not going to be dealing with integers anymore. We want to deal with real numbers, like 2.3786 plus 3.5289. So we would probably need different data types. Do we need different data types? Can I use the same program that I wrote previously and get the same result? Let's see. So let's say I declare my variables. Step 1 remains the same. I declare my variables. I say a is equal to 3.8769 and b is equal to 5 8 point blah, 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 so something, and the result is a plus b. And now what I want you to do is print this. So it's basically writing the same program again and using placeholders for integers. So this should say the answer of a plus b is equal to the result, b result, and let's see what this does, what this gives us. So compiling the program, I mean it's called multiply right now, but yeah, let's just call it multiply. I call this output. Uh, so I seem to have warnings. Man. Let's see what the warning says. It says that there was an implicit conversion from double to int, and this changes the value from 3.8769 to 3. So you know what this means? So if you get a warning, you can actually execute a program. It says it should print A, which has the value 3.8769, but it printed 3. And this is because we defined these variables to be integers. Their data types were given as integers, but on the right hand side we enter a real number. And that's what the problem is. So the computer says that I'm just going to take the integer part of the real number because you told me this is going to be integer. Don't fuck with me. Don't cheat with me. You told me you wanted me to take and play with integers, but now you're giving me real numbers. That's not done, man. So I'll just take the integer part of it. So it does not round it or anything. It takes the integer part of 3.8769 as 3. The integer part of the other number, as you can see, it just takes 8, converts the value from 8.7997 to 3 to 8, and the answer generated is 11, which is 3 plus 8. So do not cheat the computer, man. Don't cheat the computer. We want to use a different data type, right? We don't want to just use the data type int when we want to use real numbers. So we have to use a different data type, and this data type in C is called double. You saw it previously. Double means we're using real numbers. Okay, and let's get back to the thing we were trying to do. We're trying to multiply things here. So let's use something that we can actually check by our eye. You know what I mean? Uh, so 3.1 times 8 is 24.8. So we know the answer. So uh, let's see what happens. Will this give us the right answer? This is my question to you. This again generates a warning. What's going on, man? Yeah, so the thing that's going on here is, remember that earlier the warning was generated at the declaration because we declared a to be integer, but we entered a real number. Now it does not have that problem anymore. Now it has another problem. It says that the placeholder you entered was for integers, but you want me to print a real number. That's not done. Hey dude, stop cheating, stop messing around. So it's giving me a warning. It's giving me a warning. I entered at three places I entered that, hey dude, uh please print an integer, but all the three places I gave it a double or a real number, and it's giving me a warning. And let's see what it outputs. It outputs trash. It outputs complete trash, and this is because the computer says this is not done, man. You have to stop cheating with me. So the way we correct this, the first thing I should do is add a line break here, of course. Should have done that previously. And uh, the placeholder should be a placeholder for a real number or a double, which is %f. So should I get that integer should be %I maybe, and double should feels that the placeholder is %d. That's not the case. So remember, I'm writing it here, placeholders for integer, it's %d. For double and float, float is similar to double, but you can always just use double, not float. If you have memory considerations, you might want to use float, but doesn't matter here. And then you use %f for double and float, and we'll see what we want to use later. So this should give us the result. Oh no, oh shit, so these are comments, of course. So if you I should have used the commenting double slashes, and I still have yeah, so this should not give any error, and it did not. Neither did it give any warning. So now I want to output it, and yeah, it's right. It says that the answer of 3.1, oh shit, so it does have one small mistake. It says plus, so it should say multiplied, or I could just say this. So this should give me the result, which is the answer of 3.1 multiplied by 8 is 24.8, which is great, which is correct, and which is what we wanted. And we were introduced to another data type called double. Now there are other data types as well. There are many other data types, and it kind of gets irritating how many data types are there. You can check them out. There are Boolean data types, there are unsigned integers, signed integers, which is basically int. There are floats, which we didn't use. If you use double, you can always don't not use floats. And there are characters and strings, which we'll use later, but for arithmetic, for math, int and double are the two most used data types, and that's what we use. So that's it for this video where we talked about data types. In the next videos, we might talk about characters and strings and stuff like that. So watch out for that, and I hope you enjoyed this one. Keep coming back, guys. See you later. Hey guys, welcome to this new video where we'll step up in learning C. In this video, we'll learn two things. So brace yourselves. We'll learn two concepts. One is called taking input from the user. So till now, we were just printing stuff out in the terminal. So we were just kind of giving output. And in this file, this code, we'll be taking input from the users. Plus, we'll be using a conditional statement called the if, the very famous and popular if statement. So, if statement basically just does something if what is in the if statement is true, basically. So that's what happens. So the program that we'll be writing is divide two numbers. And let's open the file divide two numbers, and remember to include the libraries. And even now we're just working with the standard input output library, so stdio.h, and then write this line, do all this mindlessly, mechanically, and now we're ready to write our code. And the code has again the following things, following structures: indent your code. So indentation is a must and something that you must and always do so that your code is readable. When you write big codes, it becomes a problem. Codes stop being readable. So always indent your code. And the second thing you do is declare all your variables in the beginning. Okay, declare all your variables in the beginning and then initialize those variables after that, but declare them in the beginning. So now what we want to do is we want to divide two numbers, but we want to take these two numbers as the input from the user. So we don't want to, put these numbers inside the code. We want the user to give us numbers. And the way we do it is, first is step one is the same. So step one is declare your variables. So let's say the two variables I'm using float or double. I used double previously. Let me use float. The difference between float and double is in precision. These are the exact placeholders. So in case you're using double, always use LF. In case you're using float, always use %F. The thing is that if you're printing something, it doesn't mean it doesn't matter. But if you're taking input, it does matter. So let's say in this case, if I'm using float variables a, b, and result, so this is declaration of my variables. Now remember, I want to take user input. So the next step that I do is I take user input. And the way user input is taken is using a command called scanf. And how do you take an input? It's basically like printf. So you put double quotes in here, and then you specify a placeholder for which you want to take an input. So right now I want to take input to two numbers, a and b, which are floats. So I specify two placeholders for two floats, and then I specify the variables where this thing should go, where these variables should go. So these variables should go in a, the first, so I use and %a, and then I use and b. So this statement means that scan or take the user input, yeah, and let's write it in two separate commands. So the user input, and the first user input should go in A, and the second user input should go in B. And a better way to do this would be to accompany this with a printf statement. So make it like kind of official. Enter first number, and then printf enter second number. So you've taken user input, it's stored in A and B, and now this is how you take the user input. Let's try and print the result. So the result can be printed like this as well, actually. Let's see this shortcut. This is so amazing that you can do this. The answer is equal to %f, and this is a divided by b. So this is what your answer should be. Make sure you don't enter 0 as the input. So let's try and see what we get as output. So it's asking me to enter the first number. I enter 4.2. It's asking me to enter the second number. I enter 2. And the answer is 2.1. This is so amazing. And I also now know a shortcut. So this is great, right? So again, here we learn two things, not just that, taking user input, but there was a second thing. We wanted to learn the if statement. How do we use the if statement? So to use the if statement, well, let's just say I want to store my result in the variable result, but I only calculate the result if certain conditions are true, and those conditions are basically that if b, the second number, is not equal to 0, only then calculate the result, which is a divided by b, and then print that the result is the result variable, else print that don't divide by 0, dude. And that's it. So the thing we do is, this is how you write the if and else statement. Thing is that if there is more than one statement in the if condition, you have to use the curly brackets again. So you gotta use the curly brackets if there is more than one statement here. As there's only one statement, I can avoid using the curly brackets here, or I could do it so this, something like this, and without this would mean the same thing. What the if condition does is that the if condition is executed only if what's inside the bracket is true. And if this is true, if b is not equal to 0, it only divides then. Otherwise, it prints this. So it does only one of these two things. Either it does the thing if, or it does else. It does not do both. So let's see if I made an error here. I always make errors. I don't think okay. I did not. That is miraculous. So enter the first number, I enter 4. Then I enter the second number, I enter 1.5, and I get the answer 2.667. Let's do it again. I enter the first number 4. Now I enter 0 and it says, don't divide by 0, dude. Don't do that. So that is it. That's how you execute, or you use conditionals or if statement along with taking user input. So we really stepped up here, guys. We took an input from the user and we also used an if statement. So we really bumped it up. We really graduated to the next level. So that is it. We've learned a lot more about data types. We've learned 3 data types now: integers, floats, and double. Okay, and we've learned the if condition, and we've learned a lot of other things: how to compile a program, indenting your program. One more thing I'd like you to pay attention to. Now, this if condition, I've indented the statements in the if condition more than the other statements. So notice this indentation. So these statements are under the if condition umbrella, and these are indented differently from the above statements. So kind of makes the code more readable, don't you think now? I think it does so, and it's also kind of standard practice. It's always something that's done by programmers worldwide, and it's standard practice and it's good practice. So you should always do standard things. Like if you're in a country where everybody overtakes from the right, then you should always overtake from the right. Don't overtake from the left. So you should always do standard practice, and then you should always do good practices as well. And this indentation thing is actually both a standard practice and a good practice. So do both. And this is it. This is it. This is all the knowledge that there is to give in this video. I hope you really enjoyed it. I hope you did feel like you stepped up, learned more things that we usually do. And I'll be back in the next video, and hope you guys are too. And until then, enjoy learning. Have a nice day. And hey guys, welcome to this new video. And we've stepped up. We're learning two things in the same video. So again, in this video, we learn two concepts. One is the concept of an array, and the next thing is the concept of a loop. So let's get started. And here, what we do is we take user input. So that's the program. What it does is it adds numbers. Let's say it adds numbers, and I call it add numbers dot c. And what this, so again, before we start, just include the standard library, and then write the int main statement, and let's go from here. So let's go from here, and what we do now is we write a program that does the following. So it takes user input, take three numbers as user input, and outputs the sum of these three numbers. So this is what I want you to do. Yeah, this is what I want us to do in this program, and this will teach us the concepts of loops and arrays. So let's say I want to do it for three numbers right now, and I want to do it using the existing knowledge I have. So what is the code that I need to have in case I want to do it? So the first thing, let's quickly go through it. I'm not going to explain what I do because I hope you know all this. And this will tell us the need of using things like arrays and for loops. And I want to come at it naturally. Like, why do we need such a thing? Like, we came at the if condition naturally. Like, we need if conditions to check if I want to do something or not. Similarly, we need for loops and arrays. So let's do it using existing knowledge. So first, you use step one. We declare the three variables and the sum. And then we take user input. So we ask the user enter A, and then the user enters. So let's say this is not int now, this is double. Okay, so everything is double. So I have scanf, and it takes a user input into double. So remember the placeholders. This is kind of important when it comes to taking user input. If you're printing, you can use whatever you want really, but if you're taking user input, to take user input into float, it has to be taken through %f, and for double it has to be taken through %lf. So it has to have lf over here. So you take the three user inputs and into A, B, and C, and then you sum them up, a plus b plus c, and then you say that uh, print the result. So the result, the sum is %lf, uh, and this variable is sum. So let's see what this does. GCC add numbers minus O output, and I have a bunch of warnings. Why do I have a bunch of warnings? Okay, so there are places. Maybe I just don't need that. Okay, so maybe here I was wrong, and we just need %f for double as well. I haven't written a code for a long time, so please excuse me. I don't usually use C a lot, so maybe I was wrong here, but let's get rid of these errors. There were still some errors. Oh yeah, of course. I am so stupid. So this was correct. I did not assign where it should scan. That is so stupid of me. It should do it over here and something like this. So yeah, this should do it. It did. So it was correct. Use scan LF and not scanf. So let's quickly see what the output is. Enter number A 3, number B 4, and the sum is 12. So this is correct. So this program is correct and really easy. Now the question that arises is, what happens if I want to take not 3 but 5 user inputs? You know what I mean? 5 user inputs. That gets difficult, man. I mean, I have to just keep repeating this code again. You know what I mean? Just printf scanf 5 times and then add it here and then have declare 5 variables here. So I want to reduce the amount of code I write because the code should be scalable. If I want to add 3 numbers, I might want to add 100 numbers at some point. I should write a scalable code. So the first thing that I want to correct is that here, if I have to add 5 numbers, I would have to do it like this. So, and this is something I can correct by using an array. So this is an array which is defined as, you could say, so I'm still doing it for 3 numbers right now, is defined as a group of variables, you could say. So it's a group of variables, and this is how it's defined as. So this means that A is now not just one variable, but a group of variables, and this group has size 3, so it's a group of 3 variables. And these 3 variables, so it's a group of 3 variables, and these 3 variables are A0, A1, and A2. So these are 3 variables, so it saved me a bunch of lines. Now if I want to do 5 variables, I just write 5 here, or if I don't want 50, I just write 50 here. I just don't have to keep on adding the variable names. At some point I was going to run out of letters as well, but this is what I do. And instead of A here, I write the first variable in the group, which is A0 here. So these arrays or these variables are indexed from 0 to n minus 1, where here n is equal to 3. So I write 1 here and I write 2 here. And this statement then becomes something like this. So I have saved myself some headache by not having to declare 5 new variables or 50 or 100 new variables. I just did it using this line. And this will give us the exact same result as what we were getting before. So let's compile, let's run. 1, 2, 3, the result is 6. Cool. Now, this was a minor change, but this introduced us to the concept of arrays. Now comes the concept of a loop. So what I'm doing here is, in a loop, I am taking input from the user and I'm adding all the inputs. So can I use a loop? A loop is a part of the code that is executed in a loop, which is like one after the other until you tell it to stop. So it keeps executing something until you tell it to stop. And here we're using a for loop, and this is the syntax. It might seem a lot if you're doing it for the first time, but this is how the for loop is written. For the for loop, first you need to define an integer I, and then you say that I want to run my for loop for the counter integer I. So I is a counter, is something that counts, and I want to start this counter from 0, and this counter should go on till I is less than 3, and this counter after every iteration should be incremented by the value 1. And this is what the loop should do. So let's do one thing. Let's just study this loop for a while. And I'm commenting everything out. One way to comment was using double slashes. Another way to comment was using this kind of thing. So this comments, double slash would comment a line. This comments out the whole block. Now I want to study loops. And I've entered this loop, and this says that I'm going to start using an integer I as my counter, and the counter starts from 0. So look at this first, and then look at the last statement, which says that the counter should be incremented by 1, and the loop should go on till I is less than 3. So let's see if it does what I said it should do. Let's print I, or the counter, at every instant. So let's do it. Oh, sorry. There needs to be a semicolon. See, this is the irritating thing. You need to put a semicolon all the time, and you might miss it a few times. It becomes a problem. So what it did was it executed the command in a loop, and it said that the counter value in the first iteration is 0, then it's incremented by 1, so it's 1, then it's incremented by 2, so it's 2. So this is how it's done. If I change this 3 to 10, then this for loop is executed such that this counter I begins at 0. It's incremented by 1 after every iteration, and it's only incremented till I is less than 10. When I is not less than 10, this loop is not entered and it exits. So let's see what the output of this would be. And it goes from 0 to 9. So you see, this would go on from I is equal to 0 till I is less than 10, which means it goes from 0 to 9. So another thing you can check is, so instead of I is equal to I plus 1, incrementing it by 1 every time. If we increment it by 3, I will get something like this: 0, 3, 6, 9. Pretty cool, huh? Now let's see how we can use this in our program. I want to increment this by 1. I just want to take input of 3 numbers, and I want to take input of 3 numbers, right? So this is how I do it. I print this command inside the for loop. What I say to this is enter a number, and instead of 0, I enter I, because in the first iteration the value of I is 0, so it inputs the number into A0. The second iteration the value of I is 1, so it inputs the number into the position 1. And in the third iteration the value of I is 2, so it inputs in the third element, or A2, which is pretty cool, right? So I had this whole bunch of code, these 6 lines, and I was able to reduce it to these 3 lines. And these 3 lines will always remain 3 lines. If I want to take input of 10 numbers, I would have had to write 20 lines, but now I can do it in 3 lines. I just have to change this 3 here and this 3 here. So pretty simple, huh? Makes it easy, makes the code smaller, reduces redundancies. So my code is significantly smaller now. So let's see if this works. It says enter a number, I enter 2, then enter 4, enter 6, and the sum is 12. Now, there's another thing I can do. The other thing I can do is, now if I want to do it for 5 numbers, I can just write 5 here, and I can write 5 here, but I would have to add A3 and A4 over here, which is a problem. So I want to find a way where I can sum things up in the loop as well. So the way I do it is I use a trick. I use a trick so that I can sum it in the loop. So I initialize. So this is the way to initialize and declare at the same time. So this is declaration plus initialization. I say that the value of my sum is 0. It is 0 initially, and how I find the sum is using this command. So now I never, and I can remove this, and I never have to edit my code apart from these 2 points, and I can even write 10 here, And what this does is it starts with 0, the sum is 0, and in the first iteration this is 0, and it adds the first number to it. In the second iteration, this is now equal to the first number. It adds the second number to it. Now the sum becomes the sum of the first and the second number. And third iteration, so I think you get what I mean, just keeps adding. So you initialize it to 0, and you can do it for 10 numbers as well. So, and the code just will always remain the same. You can do it for 100 numbers, and this will always remain the same. Let's try and do it for 10 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the number is the answer is 55. It's beautiful. So this is it. I think this was probably the heaviest video in terms of learning things that we've done. We learned for loops. We learned how to take user input using for doubles. I mean, we already learned it, we practiced it again, and then we used arrays and what arrays are, and then we used for loops, which are kind of really interesting things. And notice again that I indent the statements inside the for loop in a different way than the statements outside the for loop. They are the same type or same indentation, and these are inside the for loop, so they are indented differently. But yeah, this is the code to add any number of numbers. So you can add n numbers. And you might say, okay, you have to specify 10 here and 10 here. But yeah, that's it. That's all you have to do is specify it over here. There is another thing you can do so that you don't even have to specify it. I can always do that over here. I mean, it's not good practice usually, but why not? Let's try this thing. Uh, uh, Take user input of the number of numbers you want to add. How many numbers would you like to add? And then scan it, person D to N, and then define your variables using N. So, okay, yeah, there should be a person's and sign here. So yeah, this is it. So this should be correct. And now if I say I want to add 5 numbers. Okay, so it says enter a number 2, 3, 4, 5. Gives me 15. So now all I have to do is nothing. I just have to run this program, and I also don't even have to specify. I don't have to specify a thing in this program. I don't have to specify how many numbers I want to add. I mean, I have to specify it, of course, but I don't have to hard code it. So this is totally a program for the user. It's not no a user does not have to go inside the program to change things according to its functionality. You can just always use it. You can also input how many numbers you want to add and go forward from it. That's the thing. This is not usually done because people like to declare everything before and not use the declarations. So what's done, yeah. So we can also use global variables, stuff like that. So this is not important, but there is a way you can do it where you don't have to hard code anything. Here, the achievement of this program is that I haven't hard coded anything, and I can sum as many numbers as I want. It's such a great thing. I don't know if you can feel it, but I believe that my task is reduced so much. I could actually sum up 1,000 numbers, and my code will be just this much, and don't have to change one line of code. That's how amazing this is. So, just remembering again what we learned something about the placeholders. So what we learned was, again, taking user input, why we need arrays, and we learned how to define, declare array, and use them. And we learned why we need for loops, or why we need loops. Basically, there are different kinds of loops, and we used a for loop and a bunch of other things. So I hope you ignore this. I don't know what I did. Okay, yeah, I got it back. So yeah, I hope you enjoyed this video, and